Hello, we are students from Embry-Riddle Aeronautical University's Spacesuit Utilization of Innovative Technology Laboratory, or SUIT Lab, and we are working to solve real problems for human spaceflight. The SUIT Lab consists of two teams. The MicroG Next team is creating tools for NASA's Artemis missions to the Moon. We design, manufacture, and test prototype tools for real NASA missions. We then send our prototypes to NASA's Johnson Space Center in Houston, Texas, to be tested in the Neutral Buoyancy Lab. To date, we have created Star, Archer, and now Luna Moth. The Suits team is creating an augmented reality interface for astronauts. While on a spacewalk, the display shows human vital signs, navigation, and tasks. Named the Augmented Lunar Exploration and Extravehicular Interface, or ALEXI, this device will enhance an astronaut's ability to complete real missions. In order to accomplish the goals of these projects, our teams employ the engineering design process. First, the problem to be solved must be identified. Working in space presents many unique challenges. For example, there is lots of dust on the Moon, which can interfere with the use of tools on a spacewalk, and large spacesuits can make it difficult to access those tools. Next, we define our requirements. Our device must be easy to use, tolerant of lunar dust, and be able to securely hold tools during spacewalks, and be small enough to fit on the spacesuit. Next, we brainstorm ideas. We researched and created ideas and picked what features we wanted to include in our design. And then, we built our first prototype. An important part of the engineering process is going back to previous steps when needed. If a problem with our design is found while a prototype is being built, we can go back to brainstorming to change our design. After we have built a prototype, we test it. In order to test tools designed for space, we need to simulate the conditions that an astronaut experiences, including weightlessness. We test all of our designs underwater, where we can use buoyancy to mimic reduced gravity. We use the tool just like an astronaut would, while looking for ways that the tool might not work or be unsafe. Again, if a problem is found, we go back to previous steps to change our design or how we build it. The tool we finally give to NASA has been rigorously inspected, tested, and redesigned to meet and often exceed every requirement. The tool will then undergo NASA testing in the Neutral Buoyancy Lab. The SUIT Lab team directs the testing session, in which an experienced diver will give feedback about the tool. This final step allows the team to reflect on the design and evaluate its success, the final step of the engineering design process. These challenges have given the SUIT Lab the opportunity to develop engineering and operations expertise as we learn through this classic iterative process. Luna Moth and ALEXI are the latest of our projects, and we look forward to the next steps.